value for the current source. Alright, so I see a question, So watch this. This for the super loop, right? So watch this. You have a current source here, and you have a current source here. So let me do step one first. So step one was to draw the loops, which they have done already. So notice clockwise, 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 right? And they label it I1, I2, I3, and I4. Real simple. Step one done. Label it, draw the loops, make sure it's in the same direction for all of them. Step one complete. Step two, we need to look for super loops. So basically how we just do it, you look for all the current sources. So you have a current source here, you have a current source here. Yeah? So you need to look to see if it joining or if it in between two loops. Alright, so you notice for this current source, I1 here, and then I2 will be here. So therefore, this entire thing here, you have a super loop. Yeah, and then where the next one is. So you have here now, this current source in between the loops I2 and I3, you can see in there, right? So this joining I2 and I3. So if I draw any current, I3 will be here, and I2 coming down here. So therefore, this will be a super loop. So you just treat this whole thing here as one. All right, so just an example. All right, so that is how a super loop will look. It just happens when you have a current source and it joins two loops together. It literally intersecting two loops. Because if you notice, let me just erase this. Watch what will happen. Why it's important that you need this. So if I'm looking at the I1 loop, right? If I go in here, up here, oh, there's one. It crash. I saw that thing sticking. What's Microsoft Edge? Oh, it come back, right. So you go in here to here, then up here, here, and I'm going back to it. If they call this A, B, C, D, I'm back to A, right? So if I do any loop A, B, C, D, back to A, right? Watch it. So if I go in from A to B, nothing happening, that is okay. So I go in from B to C. So watch it. I go in through a resistor. So it'll be minus 2I1. Alright, so that happens. From B to C, we have a drop. Then we're going from C to D, we have nothing again. But now we have to go from D to A. Yeah, but you notice you have a current source. You don't know the voltage drop across it. So you have a problem. You can't write anything. So you're gonna be stuck right there. Be like, what gonna write for the voltage drop across the current source? You don't know. You just don't know what it is. Alright? So to do that, all you need to do, since I2 and I1 are the two loops that the current source connecting, you just join the two loops together. So we can call this A, B, C, D, E, and F. You just join it together. So now the loop will be A to B to C to D. But instead of going back to A, we're not going to E. Now we're not going to the current source. You just act like the current source not there. Alright, just act like it's not there for now, right? So your loop is this here. So it'll be C to D and back to E and to F. Alright, but in this question here, it's a little more complex because now we have to go through this. But for now, just act like it's just a Y, just for understanding purposes. I will show you what to do when you have that in a bit. So now we're going from A to B to C to D, go through here to E, back through here, and you have to go through this here, which is 6. So since you're in the I2, it would just be minus 6I2, and you're back to E. And that is equal to 0. Yeah? So that is it. You just join any two loops that it connects. You just acting like this now here for now. So it just be pow, 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 pow. That will be the loop, the super loop. Right? And then as usual, I already link equation for the super loop. So as I said, is the current that going in the same direction as I1, subtract the one that going against it. So if I draw it, I1 go in here, and then I2 go in here. If I follow the story, right? So I2 going in the same direction. So it will be I2 subtract I1, because I1 going against it. will equal to 5. Yeah, so the one that going with subtract the one that going against will equal to the current source, which is 5 amps. All right, and this is how you treat with a super loop. All right, let me try the other one. So continue to, so let's try the other one at the bottom, which we assume wasn't there. So if I use doing the other one now, for that see this color, choose a different color. All right. So if we had this now, so I2, say we need I2 loop, for example, we an I2 loop. So we'll go here. Let me just assume this now here for now, right? That's for understanding purposes. That's how I so go in here, through here, and down to here, right? So you go in A, B, C to D. So if I go in through, I go in up here, so it'll be minus 6 I2. Okay, go in try resistor, right? Then you go in for B to C, that's nothing. But then we're going on here now, pressure. You can't go through that, you don't know the voltage drop across a current source. So when you notice that, you have to do a super loop. Alright, but the reason why I'm showing all of this is to let you know that you can't do the normal KVL equation when you have a super loop. You just need to notice it first and treat it as a super loop so you have to go through this pressure. Right, but that's showing you. So we can't go through this. So when you notice that, you need to join the two loops that the current source connect into one. So therefore it'll be this I3 and I2. So it'll be A, B, C, D, call this E and F. So it will go so, and back. Super loop. So if I do it, I'll do it on the left hand side. So if I do it for I3, so yeah, that's like normal. So I go in A to B, so it'll be minus 6 I2. Going through here, going through. Now we have I4 here. So I4 is in the I3 loop. So it'll be minus 4 I3. All right, then you're going down here. All right, so watch this here. Watch this carefully, right? This resistor 8, it's not only in the I3 loop, it's in between I4 and I3. So what we're going to do with this? So I3 going down here, which is good. And then I4 going up here. Watch carefully what I'm going to do here, right? So this resistor here will have two components. One will be positive, one will be negative. The one that is negative, I3 will be in the I3 loop. So any resistor that I3 going through will be negative. Any current going in the opposite set through the resistor will be positive. So what we're going to do here? So for I3, it will be like normal, minus 8 I3. But since I4 going through it in the opposite direction, it will just end up being plus 8 I4. All right, and let's come back. That's how you would treat with that here. When you have two current sources going through the resistor, that's how you treat it. One will be positive and one will be negative. The one that's negative is any resistor that in the loop that you assume will be negative. Anything going against it will be positive. That's simple. So now we at F, and I go back to A, and it done, so let's make it equal to 0. Yeah? So now we are running like the equation like normal. So we here, so we need to know what the current. So I3 going this way, and I2 going down. So same thing I told you, all right? The current are going in the same direction as the current source, minus the current are going against the current source, what equal to the current source, 3IO. All right. All right, it's nice. So if I write in the link equation, now I have to write the dependence. So because IO is a dependent, so try to solve a dependent source of a equation. I'll remember that. So IO, if I look where IO is, IO here, which is in the I4 loop. Right, so we're just carefully. I4 going clockwise. So I4 going down here, right? IO going against I4. So all IO will just be, IO just be minus I4. Okay, going against what I assume. If I assume all loops was anti-clockwise, like it was going this direction, I4 will equal to I0. But since I assume the loops went up clockwise direction, and they gave my IO going down, which is against I4, IO just equal to minus I4. Yeah, as I polarity is important. All right, so check the questions. All right, nice. So that is how you treat that super loop. Just keep your mind on it. Keep your mind on it. We're gonna do more questions, but just remember, super loop occurs when you have a current source in between two loops. All right, let's keep your mind on that. And when that happens, you treat the entire loop minus 8. What this? This one here, minus 8i3. So that happened in this part here. So if I need i3 loop, so this i4 is i3. This here is i3. But what happened with this one here, anytime it go through, I resistor will be negative. So that is why I got the minus 8i3. Alright, so let me just erase that part. I'll do that part alone so you could see. So let's erase this. So watch carefully, right? Watch carefully. Alright, I'll ask any questions so you can understand the concept. If I had a wire here, let's treat that as a wire, right? So if I do any loop equation for this loop alone, if I start in here, going through here, coming down here, and going across here, that's the loop there, right? Watch it. That's understand the concept here now. So I'm going from A to B to C to D. Yeah? So remember I need I3 loop, right? So any resistor that I3 going through will be negative. So if I write in the equation for it will be minus 4i3 because I'm going through 4, right? And I3 going in this direction. And the voltage drop across will be negative, right? Now we at B now. Now we have to go from B to C. So look what happening in this loop. You have I4 going up here. Yeah? Because this resistor here in between two loops, right? And you have I3 going down here. Watch it carefully, watch it. So you have two currents going through here. So you have to treat them differently, right? So as I said before, I3 going through 8, right? So any resistor that I3 going through will be negative. But any current going in the opposite will be positive. So that is why when I went from B to C, this 8 here, I3 going through it. So it'll be minus 8i3. Yeah, that is where I'm getting minus 8 from. But since I4 also going through 8, I need to account for that also. So since it's going opposite to I3, anything in I3 direction negative, anything going against it will by default be positive. So I8, this 8 here will just also be plus 8i4. And it will just equal to 0. Okay, going back to D. Yeah, and that is it. That is where I got the minus 8i3 from. And that is where I got the 8i4. If anyone have questions for that. Anytime you have a resistor, you're in between two loops. So this 8 resistor, think about it, right? I3 going through it and I4, because I4 going this way, which is going through 8, and I3 going this way, which is also going through 8. So the resistor 8 have a resultant of two of them. Yeah, so it'll be minus 8i3 because I need I3 loop. And then since I4 going in the opposite of what we assume, it will also be plus 8i4. And they just make it equal to 0 because it's a KVL. All right, so you'll get to other question, but this was just to demonstrate the super loop. All right, let me see how to know which is negative. Right, so be more specific. In this part here, so as I told you, any resistor, so I assume, watch it, right? I3 going in this direction. So what, let me draw it out. Anything going against it, so I3 here, there's I3. Red is I3. Red is I3. I'm repeating it so you can see. Red is I3. So you see any red. Anything pink, or let's say purple, anything purple is the I4. So you have I4 going here, coming down, going through so, and it's also going up here, through at 8, and coming back here. So watch it. Any currents, right? If you have a normal battery and you have a resistor and you're coming back around, any voltage drop across a resistor will be negative. It will never be positive. So if you have a current, if this was R, and I wanted the voltage drop across this, it will be minus I1R. It's the same concept we're using for here. So since I need I3 loop is the red, right? I in red. So I'm starting from this A, and I'm going through it. I need I3 loop. So therefore the voltage drop across this will be minus 4i3. Real simple. Minus 4i3. Now I add B. Now I'm going through it. And what you notice with 8 is that you have the purple going in the opposite to I3, and you have the red which going in the direction assumed for I3, right? So just like we did before, any resistor that I3 going through will be negative. Just like we did before, real simple. So that'll be minus 8 I3. That is it. But since we need I3 loop, I3 going red clockwise. Look at 8. You have the purple going against it. So since we assume anything going through the resistor negative I3, it's real simple. If anything going in the opposite direction, it have to be positive because it's going opposite to what we assume. Yeah, it's not rocket science. It's that simple. We in the I3 loop, we're going up so. This 8, you have one going down, which we know will be negative across it, and you have one going in the opposite direction. So the one that go in the opposite will be positive in this case. If the opposite will be true too. If we assume the current voltage drop across the resistors is positive for some weird reason, which will never happen, it will be positive I3, and anything going in the opposite, sorry, positive at 8 here. This will be negative. And anything going in the opposite to it, this will just switch to negative. It just will be the opposite. But we don't assume voltage drop across resistors as now positive. We assume it to be negative in the current direction that we assume. But anything that will go against that will be negative. All right? So just remember that. We'll practice it more, but for now, just remember the concept. All right? So now you continue to more questions. Well, I stated this already in the first part. All right, so let's watch this one. Let's do this one from scratch. So watch carefully what I'm going to do, right? Watch carefully, all of you. So we have this. We need our loops. So obviously we have a loop here. We name this one I1, right? We have a loop here. We name this I2. Name this here I3, I4. All our loops are just mini boxes. Let's show it is. Nice. So we need to write the equations for each of them, right? So we can just go, that's like normal. I'm just scroll down so I get more space. Yeah, so similar. So let's write the loop equation for I1, right? So I1, so let's do it. So we go in a clockwise, right? So it don't matter where I start. So if I start from here and I go up here, come back around here, come down, and I went back. So there's the loop here. Yeah, that's the loop for I1, right? So let's go. So this battery is going from a negative to a positive, right? So that voltage rise. Starting from 1, 2, 3 to 4. Right? So 1 as our rise. Negative to positive is our rise. Real simple. So that'll be 12. So we have 2 now. We are not to go to 3. Now we have to go through R1. So watch it. Anything in going through I1, we need I1 loop, I remember that. So any resistor that I1 go through will be negative. And any current going in the opposite to I1 through the resistor will be by default positive. So watch it. So we need I1 going through here. So it'll be minus I1 R1. And anything going in the opposite will be positive. And then we positive I2 R1. That is what happening here. I2 going here, up, and I1 going here. So anything I1 here, the voltage drop across here will be negative for I1. But since I2 also going through the resistor in the opposite direction, it will be positive. Yeah? Keyword is opposite. If it's negative for this here, if something going in the opposite to it, it will just be positive. It's that simple. Nothing rockets. And you go back down to 4, and then that is equal to 0. Yeah? And that is the loop equation 5. So if we go to I2 now, same thing. So when the I2 loop now, so where I can start, let me use a different color. So that we use green. So we'll go from here, name this 1 up, name this 2, across here, 3, and down, well, 4, and then back to 1. So this green here is the loop for I2. So let's write it. So we starting from 1. So now we're going through R1. Same thing I told you before. So you notice in this resistor, you have 2 currents. I1 coming down and I2 going out, just be the opposite. So since I in the I2 loop, the voltage drop across R1 will be negative. And anything going in the opposite, since I1 going opposite it, so that's gonna be in plus I1 R1. Look at it, it's just the opposite. Because remember, any I1 loop, anything that I1 go through will be negative, and anything going in the opposite will be positive. Or when any I2 loop, since I2 is the loop now, anything that I2 go through will be negative, and anything going in the opposite direction to it will be positive, which is what you see here. Yeah, just the opposite. So I continue. So going up here, we are 2, 3, nothing happening. Now we're going through R2 now. Same concept. So we have I3 going up, and we have I2 coming down here. So any result that I2 go through be negative. So it's going to end up being minus I2 R2. But since I3 going in the opposite direction to what we assume, it will be plus I3 R2. And it will equal to 0, because you back to here and you back to where we start. Look, equation complete. And there we go again. For the other loop, continue the same thing. That's where to catch it. So if we start here, name this 1, we name this 2, we name this 3, 4, and back to 1. So there's the loop here. Anything in this direction would be negative, right? Anything going in the opposite, positive. Same thing. So I3. So we start another one going up. Same, you notice 2 currents. So you have I2 coming down and I3 going up. So anything that I3 going through will be negative. So it'll be minus I3 R2. Anything going in the opposite of what we assume through the resistor will be positive. So it'll be plus I2 R2. If you notice, it's literally the opposite of what you had here for that part. Alright, because in this one, anything negative, in this one, negative. That's swapping it. But it's the same concept. So where we have now. So we went through, we went up here. So now we have 2. So we go through here, and we're going through R3. So in R3, you have the same thing happening. I3 going down here, but I4 going up against it. So same thing gonna do. So now you have minus I3 R3, and then anything going in the opposite direction to what we assume will be positive. So that'll be plus I4 R3, and is equal to 0. Same thing we just did before. I'll do it again. Real fun. So I4, same thing. So now we're in I4 loop. So anything that I4 going through will be negative, and anything going in the opposite direction to I4 through the resistor will be positive. Yeah, I'm repeating it for a reason, because it's the same thing. So like I say, we start here, 1, going up here, 2, across here, 3, down, 4, back to 1. So the loop will be this. Anything in this direction, negative. Anything opposing it, positive. So now we start at 1. So going through R3, but you notice R3, I4 going up, I3 coming down. The same thing. Anything I4 going through, negative. So it'll be minus I4 R3. So, and then it will be plus I3 R3. Because R3 going in the opposite direction to what the loop we have, the direction the loop we assume. Yeah, that's it. And then so we have 2 now, sorry. Going across to 3, then we down to 4. Since R4 have no other current going through it, but I4, you get through. So this will just be minus I4 R4, and is equal to 0. Yeah, that's your 4 equations there for the loops. Is you notice the same thing I did over and over and over. You just have to remember, you assume this. Anything going in direction against that in direction, you assume be negative. Anything going opposite to where you assume positive. And that will happen when you have a resistor with 2 currents going through it at the same time. But you notice an I4 loop, only the R3 had 2 currents going through it. R4 only had 1 current, so you only have 1 current, you won't have anything positive across it. And that is it. And that is your loop equations. Yeah, that's all it is.